Good afternoon, ladies and gentlemen. Welcome to the Railway Industry Association hosted Knowledge Hub. My name's David Clark. I'm the Technical Director at the Railway Industry Association. A big crowd, I see, so clearly you're looking forward to an interesting presentation from David. I don't think David Waboso needs too much introduction, but I'll try. David is Group Managing Director of Digital Railway, and I don't think you could find somebody with a more relevant CV for that role. You're probably all aware he has a long and distinguished career working backwards, TfL, major programs with a long list of successful programs there. Before that, the Strategic Rail Authority, and before that, Jubilee Line Extension. Before that, I believe a spell as a maths teacher as well.
Very early on, yeah.
Early on in your career. So I'm sure we're going to hear a very useful update from David, so I'll hand over to him now. Thank you.
Thank you very much. This seems to be, they put this ridiculous contraption on my head. I feel such a pillock. Never mind. Try to ignore it. Okay, good afternoon everybody. Can you hear me okay? So, funny enough, I was here 2 years ago, just before I started this job, to then give you a view of what I thought it was going to be. So here we are 2 years on, and I'm going to tell you what it's like and where we are. So it's a general update. I think we've got Q&A afterwards a bit. Okay. So again, I think it's always worth restating what digital railway is and what it isn't. It is very much focused on the command and control systems of the mainline railway. Okay, it's not ticketing, it's not smart infrastructure, it is absolutely the command and control systems. Now, of course, that does allow and enable those other things, but we have focused it on that initially because it was very broad when I first came on. And a bit of history and a bit of background. The railway is this huge success story. You know, we move more people now than we ever have, and the numbers have doubled. And interestingly, one of the reasons that the railway is so popular is more and more people are now, there's a lot of feedback on this, more and more people now live a long way from where they work. So what you've seen is this massive growth in commuter traffic. So people will live, you know, an hour from London or Birmingham or Manchester or York or Edinburgh, and what you see is this huge growth in people buying season tickets to come and work in the cities that, but they can't afford the house prices or make personal choices. That's led to this massive growth in commuter traffic. Now, obviously, we hear that numbers are not zooming up as much as they have. I'm old enough now to have lived through 3 of these wobbles, and each time, by the way, they come back. So that's my view into the future. You see this large growth, as I said, mostly into our major cities. And the other thing, of course, is that the mainline industry is largely based on a colour light signalling system, which has served us very, very well. Largely to do with fixed blocks on the track, generating a colour light aspect to a driver who will respond to the signal that they see in the cab. Sometimes we still have semaphore signals, still some lever frames, some lovely quaint old signal boxes which look great but are obviously very expensive to maintain. If you think about it, the cost of somebody in those 24/7 all the time is quite a lot of money. And the key thing about this technology is it is quite constrained in capacity in certain places. Not everywhere. It is appropriate in a lot of places, but especially as those approaches into our main cities is where you have the big problem. And the reason for that is because we don't have a system yet in terms of the command and control systems. Can you hear me okay, by the way? No. Do we need to change over the microphone? Because I think they're struggling with this one. Yeah. Well, I'll keep going. I think he's telling me to shout. And the trouble is that the system we have at the moment does not allow the train on the track to communicate in signalling terms with the computer on the track. So you have a system where you've got to assume the worst possible braking performance of the train, what we call the safety distance, the overlap between the signal and the conflict point. It's saying effectively that means it's an inefficient use of capacity. That's the thing to take away. And like most other very expensive asset-based industries, all that digital railway is trying to do, this is its niche, is to get more out of this expensive infrastructure. That's the way to think about it. Railways are incredibly expensive to design, build, operate and maintain. They're great things, but they are expensive. So what we're trying to do is use technology to get more out of that capacity. Okay, because building new railways, which of course we're huge fans of, HS2 Crossrail, but as a country we can only do so many of those at any one time. So what we've got to do in the meantime is squeeze more capacity. And you do it, of course, by computerization, digital technology, putting a computer on the train and the trains that communicate to the track. So digital railway is, I don't know what's happened there. Right. So I talked about the command and the control systems. This is quite an important slide. This is what digital railway is. We use something called the ETCS, European Train Control System, and that effectively is a computer on the train and a computer on the track, and they talk to each other. It is a safety critical system. The reason we use that is because it is the only system, this is a very important point, that allows trains fitted with one supplier to move on track fitted with another supplier, so it's interoperable. Okay, and the reason it's becoming more and more popular in Europe, it provides competition. You don't always have to go to the same supplier. Don't forget it comes out of Europe where they tend to have national ATP systems, automatic train protection systems. So they do like this because it gives them a choice in the supply chain. Because it's interoperable, it means that you can have a choice in the supply chain. We of course like it not just for that reason, which is a good reason, because our railway is a very commercial railway, and it's very important that we protect the go anywhere status of a lot of our trains. Because we tend not to be like the underground where you have captive trains on a line. So it's really important to have a system that allows trains fitted with one computer to travel on track fitted by another computer. So for us it's the only system that works and provides what we want. The other major component of it is the traffic management system. Now traffic management is essentially a great big brain in a computer that looks at the timetable, and the first thing it does is what they call deconflicts the timetable. Timetables are pretty good, but they're not perfect. We have a very congested railway with lots and lots of trains. We keep growing the number of trains on the network. So it's inevitable that every now and then the timetable will have a glitch. The other thing, of course, is in the morning before the first wheels are turned, there's always a problem. You know, it's a very complex railway. You know, this train is out of position, or that track circuit is down, or whatever. There's a slight change. So you have to replan the timetable. And of course, this system can do that in a much cleverer and smarter way, and critically quicker than any human being can. Yeah, you're dealing with thousands and thousands of different problems here. So that thing, of course, enables us to communicate to this, which is in the cab, the driver's cab. You can have one of two things. You can have what we call a driver advisory system, DAS for short. Okay, and if you connect that to that, you have what we call CDAS, Connected Driver Advisory, and it gives the drivers information. Most of the time, drivers do not have real-time information about the state of their journey. So the analogy is sat-navs. We all remember the sat-navs where they weren't connected. They gave you a plan, but you used to drive straight into a traffic jam. I used to, and I was never very pleased. I thought, why couldn't it tell me? Well, CDAS effectively says if there's a traffic jam, it will tell the driver, slow down, dwell for a bit longer. In some cases, we're going to turn you back at the next station. The other thing, of course, you can do is you can automate that. You can automate the driving function, which is what is happening on Thameslink so successfully, where rather than tell the driver what to do, you actually implement it automatically. It's now connected to the traction and the braking system on the train. The train will drive itself. And of course, on the underground, most trains are like that. We're now starting to see that revolution on the main line. Of course, the big advantage with these systems, you start to get rid of the variability of human behavior. Any system, as you know, if you have lots of variability, you tend not to get the most out of it. So you start to get automation here of functions. All glued together by telecoms and data. This is a very, very, very important part of what we're doing. We need a very good, fit-for-purpose, highly available communication system that communicates between all these systems and to the driver and to the public. And of course, wrapped around it is a change program, because we've always said it's not just the technology that's changing, it's the way we do stuff. I'm going to talk about that a bit more, a very important point. If we try to do this kind of program in the way we've always done stuff, it won't work. I've always been very clear on that. So we need to change the way we do stuff. I'll talk about that in a moment. Okay, and I guess this is my slide to say we are not alone in this journey. A lot of other industries, even outside of transport, are doing what we're doing, which is using computerization, digitization to get more out of the infrastructure they've got. Okay, that's the big thing, without having to build new infrastructure. And I don't like to quote capacity numbers because everybody will say it's a generalization, which it is, but you can get significant capacity increases. For example, Thameslink is getting a very significant capacity increase because of this technology. In other places you'll get performance, in other places you'll get journey time, so it's a mix of benefits. But we've got to be cognizant of other industries, other transport modes that are using this technology to really now zoom ahead. And I guess that's my foundation for saying, and I've got a slide on this later on, that we face a very important point in our railways where we're renewing a large part of our train fleet and a large part of our infrastructure. This, of course, is the generational opportunity to bring these things together, because you're largely not then paying a huge extra to do this. Okay, if you're buying trains, it's a marginal extra cost, because all train makers make this stuff anyway. If you're re-signaling, it's a marginal extra cost, if anything. So you tend to bring those two together, and you'll see later on when I talk about the business case, that's our approach. Some of this stuff is really interesting. The fact you can now get what look like trains to be trains, but they're not trains. They're not driving on a dedicated guideway, but they're using technology. So, and of course, this stuff can be done at a small fraction of the cost of building a railway. So we've got to be cognizant of this, what's going on. So this is my point, that we are over 1,000 new trains in build. I can't remember the exact numbers, 7,000 units, carriages, sorry. And we are renewing approximately over 60% of our re-signaling in the next 50 years. So you put those two together to say we have to grab this opportunity. There's never been or going to be a better time to do this. Okay, it really is a generational opportunity, because you've got to fit the computers in the trains, which the like of Thameslink Crossrail trains have, and you've got to fit the computers on the track when you're doing re-signaling. Very small marginal extra cost, as opposed to going back later on and retrofitting. That's a huge message from me. Okay, of course, if we miss that, which we won't, but if we do, we're kind of locked into using these solutions for the next couple of generations, because our assets last a long time. And given what I said in my earlier slide, who knows where the other modes are going to be in 35 years. So it's a really important point, this. So I keep talking about the fact that we cannot do this in the same way. And the reasons we can't is because it's integrative. I'm doing stuff on trains, not just infrastructure. I have to work with my train operating companies as customers and deliver what they want on their trains, freight companies. I have to work with a franchising team at the department. I have to work with the supply chain in a very different way. We have to look at our standards, our approaches, our procurement. It's a very wide-ranging program, this. And I haven't even started talking about the people change and the training and the fact that drivers are now looking at ATO, the fact that maintainers have different kit. In fact, maintenance is changed because this kit is intelligent and can do a lot of predict and prevent. I often talk about on the Victoria line, the trains, which have a lot of signalling on, through telemetry will tell you back at the depot if something's wrong on the train. You're then able to proactively take that train out of service at the next opportunity. It just moves you, and that's one of the reasons why the Victoria line has these very high levels of reliability. So at the moment we have largely what I call a fix-on failure railway. You have teams of people poised at key intervention points for when things fail, to go and generally it's quicker to just unbolt them and put a new one in. You move from that into a predict and prevent railway. That takes you to a fundamentally different organisation, a different railway. So whoops, I shouted then. Some of the things we're doing, when I came here, the first thing I did was to engage with the supply chain, because they're fundamentally important in this journey. And frankly, they hadn't been in a good place on DR. We'd marched them up to the top of the hill and down several times. And I was determined we weren't going to do that, but the first thing is to hold the mirror up and say, what could we do differently, better? We're going to listen and act. And we talked about how we were going to drive more value in whole-of-life relationships, how we're going to make sure we deliver the benefits that I wanted to deliver on the railway, capacity, performance, journey time, and of course not forgetting safety, and how we're going to bring in innovation, which has been a very important factor for us. We started on this journey, we've gone through, I'm not going to read all of that, but effectively we've now moved from what I call early contractor involvement, which was great, to what we call the joint design group, which is doing much the same thing. So we're assembling a consortium of the supply chain, and we're saying to them, you now get involved in the early development of schemes. You look at our standards, you look at our specifications, you tell us what we need to change. So it's a really different engagement. So some of the benefits have been that we have identified how we're going to procure and deliver this in a very different way. So number one, we are now going to go for outcome specifications. Again, it sounds a simple thing to say, but for the mainline railway, this is a very, very big step. So instead of issuing a whole load of prescriptive specs, telephone books worth, we'll say, back to one of my earlier slides, there's only 5 or 6 things that really matter. We're going to specify what performance we want in terms of running to timetable. We're going to specify what additional capacity we want, and don't forget there'll be a mix of these depending on the route. Do we want more trains per hour? We're going to specify what additional journey time savings we want. So take something like TransPennine, for example, that's a journey time improvement program primarily. And we're putting a signal in the cab, will enable trains to run faster. And we're going to specify what cost improvements we want, because one of the things we're doing is if we work in a different way and make these changes and over time reduce the amount of trackside infrastructure, you'll get a much more cost-effective railway. The second thing we're going to do after outcomes is we're going to have a relationship with our supply chain through whole of life. Again, sounds simple, but for the mainline industry this is a very, very big step. The current model is I procure a capital cost contractor, entry into service, they largely walk away, and I'm left with the equipment. Most other industries, in fact all of the other ones I've looked at, don't do that anymore. What they do is they have a relationship with the supply chain through the life of the performance of the asset. And so therefore if the asset performs very, very well, they get paid. If it performs very badly, there's a disincentive. That means, of course, if I start designing this knowing that, I'll design it in a different way, because my incentives are for this thing not to fail, so I start to get more the Victoria line type of stuff, where I'll design in remote monitoring, predict and prevent. I don't want a fix on failure railway. That's very important. And the third thing we've changed is how we are now going to involve the supply chain much earlier on in our procurement. Again, the traditional model has been we will internally take a scheme and develop it down the grip stages to grip 3 or grip 4. Sometimes earlier we'll bring the supply chain in, but generally. And then we'll go to market to design it, install it, construct it. What we want to do now is bring in the supply chain far earlier on in the development and say, here's our problems, you now tell us how you think you can solve those, and bring your innovation. And we've brought in disruptors, and in our procurements we'll want to work with groups of people, including disruptors. We don't want to just work with the traditional railway suppliers, because we see that we need to change a lot here. Of course, one of the benefits of that is we are able to see in the traffic management trial we're doing on with the Western route, a very, very different way of procuring. That was a trial. So far it's working, and I'm confident we'll get a result later this year, but we're paying for that in a very different way to the traditional way. We're paying for that through the savings in what we call Schedule 8, i.e. the money that we pay out when trains are late, and that's a proxy for the hassle you're causing customers. So if customers get a better journey, we'll pay the supplier of the system, the traffic management system, more than if the customers aren't getting a good journey. That sounds inherently a very good thing to do. And we're going to be building more and more of that into our procurement. So just some of the timelines. We've got a program sort of split into stuff we're doing now, stuff we're going to do in the next couple of control periods, and some longer term stuff underpinned by the fitment of trains. Very important we fit the trains. That's been a really big initiative, and we've got fantastic support from government on this. And we can't ignore the fact that this system will not stand still. It's a software-based system. There will be future developments. We welcome that. We don't want to lock people into a time warp, but we need to procure smart. And one of the other things that's going to be in our procurement is we do want all future technologies to be backwards compatible. That's another very important message. What I don't want to do is saddle operators and infrastructure managers with a heavy cost of upgrading systems, because it's like your iPhone. The minute you walk out the shop with a new phone, there's an iOS upgrade. I know some of you will tell me sometimes it doesn't work, so we hope that doesn't happen. But you get the picture that, with a software-based system, it's a continuous relationship. It's not a one-off relationship. So we're going to be buying that support, because it's very important that people who own trains and people who operate the track don't have this ongoing bill to refresh. So we need to think about that. In the short term, we're doing a lot. We've got this thing called the National Productivity Investment Fund, NPIF for short. Very pleased that the Chancellor announced that in the budget before last. for £450 million, and we've started to draw down a lot of that. And we used the first drawdown to really move forward the train fitment program. And critically, that enabled us to go forward with fitting this ETCS stuff at our test track in Old Dalby, Leicestershire. It enabled us to let the freight contract, because freight trains are a very important part of this. They literally do go anywhere, so you've got to have a big freight fitment program. That's now started, so I'm really pleased about that. And also enabled us to look at some passenger trains, especially focusing on the ones that go anywhere, like Electrostars, Class 180s, to start that program. And also to do some other stuff around designing standards and specifications. So that was really important. We also need to start training drivers. Again, one of the big lessons from Thameslink, very positive lesson to have learned, but you've got to think early on about how you're going to literally train hundreds, if not thousands, of drivers in the different modes of operation. Okay, so again, one of the things, do we invest much more in simulators? How do we do that? You've got to allow time in the program. One of the things I do want to talk briefly about is innovation. I touched on it earlier on, but to me it's quite striking when I look at quite striking when I look at a typical railway installation, how unreconstructed it looks. And I'm not being critical at all, because I've been part of this journey. But my challenge to my colleagues is, where's the innovation? Where's the robotics? You know, I know a load of other industries are actually using robotics now to drive huge productivity and safety, because it's not safe to have loads of people trackside, you know, when trains are running. So if I want to fit an axle counter, which is the example I often use, you know, it's drilling 2 holes in a rail and clamping on a magnet and joining the cable up. You know, that to me is a very, very good thing to think about robotics. So one of my challenges has been, we need to start bringing in this innovation. Okay, we've got to start a lot more of that. Obviously, the initial deployments are coming to an end now. Cambrian was the first one. That is still the only no signals ETCS railway in Europe, so that was a first for us. Thameslink, of course, which is absolutely fantastic. Those who haven't seen it, but you know, is going to be a huge success. It's the world's first ETCS and ATO. Remember the building blocks I showed? It pulls together ATO and ETCS and traffic management. It's the world's first. So it's really important for us we've done that. We're doing some traffic management pilots, and we're learning a lot from those, and frankly it's stuff we would all do better if we started, you know, again. But the whole point about doing a pilot is you make mistakes, just don't repeat them. And as I said, we're also doing a trial on the western route. So these will form the basis, if you like, the technology foundation for how we go forward. Then looking ahead to CP6, because it's a train integration program, you always start with where's the train fitment. You don't start with what am I doing on infrastructure. This is the big difference now. You know, before NR was able to do the resignaling over here and the trains were ordered over here, and it was fine. Now, of course, they've got to come together. So that's been a big change in the way we think about planning and procurement. So this is a map which I don't have time to go into, but you can see that we're starting to get now a very significant proportion of trains that are fitted or enabled with this technology. And of course, as I said earlier on, what you need to do, the skill into the program is to join up then and say, if I align that with my resignaling program, I start to get a digital railway. And that's the basic foundation of CP6. So you'll start to see ETCS programs on East Coast, potentially Transpennine, of course all of this is subject to funding, Crew, and maybe Southwest Railways. So we need to, that's where we're following the train fitment program in CP7, Anglia and other places. Here's the timeline, a lot of stuff on it, pretty busy, but I guess it's just meant to show there's a lot of stuff happening now. We've already gone to market with a pin notice on East Coast ETCS, which is going to be King's Cross to Peterborough South ETCS. This is showing how much progress we've made. 2 years ago, this was not even thought through. We are really now starting to make progress. There'll be a lot of other procurements coming out later this year, building on what's going to be a very busy and successful year. So in conclusion, starting with success of Thameslink, I think we all need to celebrate, and in every speech you all make, Thameslink is a huge British success. The world is coming to see that. We often do ourselves down. We are still the world leaders in this stuff. It's a great showcase of British talent. We have done a great job there. I'm not jinxing it. I know it's still got some challenges, but I often talk about the Victoria line. I mean, we went through it on that line. We really did. But you tend to come through these things, and it will be a great success. We're making great progress on trade fitment with fantastic support from government. I could not ask for more support from government on this scheme. it's been great support. So we're starting to align the infrastructure with the trains. A lot of lessons learned on traffic management. I think that some of the pilots will be very successful and will inform what we then do. And as I've said, not just focusing on the technology, focusing on the people and the different way we do this. So it's a very complex program. I'll try to summarize in 15, 20 minutes. I hope you've heard most of what I've said with this contraption on my head, which I'll never do again. No photographs. And thank you for listening.
Thank you.
Hi, my name is Sagar. My question is with regards to safety, and it's with regards to the rollout, not just across the UK, but in terms of the network rail. I don't know about the underground as well. The rollout of the smart meters, the 4G and the 5G. So I don't know much about it, but in terms of safety and health, when I've read 3 EU commissioned reports talking about the health and safety on the environment of the very strong nature of the 5G, which is coming in the 4G networks, is this something being heeded? And especially when I read just a few days ago, quite a few trees are being chopped down to make way for the frequencies on the rail networks. Is this something being heeded as well? Because this is a problem that's happened in Sheffield over the last 5 years, and then it's transgressing into the rail networks as well. Especially the independent scientists saying around the world that the 5G is having quite adverse effects health-wise on us.
Okay,
Thank you.
Thanks for that. Are you going to answer that? Okay, so short answer is the DR rollout is based on 2G, it's all GSMR. It's stuff we put in all our cabs, and we're not about to throw it away. So that's going to be the basis of this. Sure, we'll need to increase availability in some places. We'll put in extra masts, but it's still on 2G technology. I don't think we felt any trees for that I'm aware of. But I think it's an important point you make about what is the future migration for GSMR, and that's something we're working with industry on, whether it's LTE, 4G, we don't yet know. We'll obviously pay full cognizance to NES on health and safety when we do that. So it's a good reminder, thanks. But for now it's 2G, so we don't see any problems there.
Thank you. Hi, I'm Graham Cross from Heathrow Southern Railway. Can I ask you a Thameslink question? So you keep saying that the Thameslink core has been fully fitted with ETCS level 2. If that's the case, and the trains of course operate with in-cab signalling, but if that's the case, why does the Thameslink core have brand newly installed line-side signals?
You can answer that. It's a really good question, and the reason that we've got line-side signals is twofold. One is for the capability to run unfitted trains should you wish to, so engineers, trains, plants, etc. That's not the prime reason. The prime reason is for degraded mode, and the decision was made, given this is the first big rollout, and I'll probably regret saying this, and I'm being filmed, so I've got to be really careful, but to probably go over the caution line in terms of should it fail. And I think, you would say if we prove the reliability of the primary system, we might not need to put so much capacity in for degraded mode. And on all you talked about the stuff, and you missed out the DLR, by the way. But we had, I've had this debate on all the train control programs: is how much do you put into degraded mode versus your primary system? And it's a really interesting debate because people always err on the side of caution. What if the primary system fails? And you end up, if you're not careful, putting in huge engines that in themselves, if they fail, then bring you down. So you kind of defeat the whole point. So as we go forward, I think you'll see more and more reliance on the primary system, because frankly, most operators I know, if the primary system fails, they just go and fix it. They tend not to run a big service on their secondary system, but that's the prime reason is there.
Hi, Mark Hookham from the Sunday Times. We heard earlier from Crossrail that they're having some issues with their ETCS. What are those issues, and what lessons are you learning from that introduction on Crossrail?
I think, Crossrail is obviously a huge project and will be a massive success. in any commissioning, which is the stage they're entering now, you'll come in. The whole reason you do commissioning is to find out the problems, and I'm sure they will solve them. I think Crossrail has got a couple of challenges in transition because it's got different control systems on it, so it has to go from one to the other. But I think they're making great progress on that. I'm not aware there's a particular problem on ETCS, and that's not me ducking that issue at all. It's just saying that I think it's just more at a system level, but I'm sure they'll get it to work. In fact, I don't want to stand here and speak for Crossrail because I'm not Crossrail, but that's the general characterisation of it. They're in commissioning, they're going to find some problems, I'm sure they'll fix them, and it's in the transition between System A and System B. It's not a core ETCS problem.
David Brigginshaw, International Railway Journal. ETCS has been around a long time now, so what's changed to make you suddenly think it's a great thing to have?
I look on ETCS as a train control system, okay? Because ETCS fundamentally does the same job that the TBTC or CBTC systems do on the underground. It basically gives a train a movement authority, and you're able to do some other stuff with it if you want. So for me, ETCS is a toolkit and a train control system. Now, I think a lot of the historical problems have been version control. We've now got a stable spec, 3.6, maintenance release 2, I think it's called, but version 3.6, and that's the one that everybody's now baselining. And I think in the past, maybe people haven't gone with the right version. They've got different versions on different parts of their network. And the other thing is the train has to be a higher number than the infrastructure. So you can't, if you've got version 3 on your train, it works on version 2 on the track, but not the other way around. So clearly configuration control is a very important national function, and I think a lot of lessons have been learnt, to your point, about the importance of configuration control, which again with my history, it's fundamental to get configuration control when you have a train control project. Lots and lots of different versions of software, hardware, firmware, data. It's important to have that under control. But you know, to your point, why am I suddenly a fan of it? I'm a fan of train control, and to me ETCS is just a train control system. Happens to be interoperable, which gives it an edge. I think the other interesting point though is a lot of suppliers are now talking about convergence, so using in the future similar platforms to do CBTC and ETCS, because they all see the direction this is going. It's a train control system, fundamentally. If you design it right, you'll get the right output.
I think if I may, just to add some thoughts to that, the original motivation around ETCS was all about interoperability and also safety. Now, of course, those things are important on any railway, but I think the approach we've been increasingly adopting in the UK is recognising that this is simply a better way to run your railway in future, and it unlocks benefits in terms of performance, capacity, and it'll cost less than the current approach to signalling. And I reference back to the presentation we heard earlier from Anna Del Vecchio from the Rail Supply Group, talking about the commitment that the supply chain has made to government to get the unit costs down to a level that's affordable. So thank you very much for being such a large and good crowd. Thank you very much. And could I ask you to thank David for his presentation?